For years, processing your digital media meant relying entirely on massive, remote cloud servers and incredibly expensive brute force hardware. That meant wasting hours uploading gigabytes of files to restrictive cloud servers, paying monthly subscription fees, and judging your hardware by metrics that no longer apply. This table compares the baseline media workflow of 2024 against the new realities of 2026 across 4 key categories: format standards, editing speeds, GPU priorities, and processing location. Notice the shifts. Heavy JPEGs have been replaced by the lighter WebP format. Manual object removal that took 15 minutes now takes an average of 2.8 seconds. Buying a graphics card based on raw rasterization has lost out to AI upscaling capabilities. And most importantly, processing has moved from remote cloud servers directly to your local browser. The gap between these legacy methods and the new standards creates a direct friction. Sticking with 2024 workflows means choosing to remain dependent on external infrastructure rather than utilizing your own hardware's capabilities. But navigating this new ecosystem isn't a one-size-fits-all process. The specific AI tools and formats you actually need depend entirely on what you do every day. Take the web optimizer. If you run an e-commerce site, your priority is driving performance, lowering bounce rates, and cutting hosting costs. Then there's the privacy-bound professional. Doctors, lawyers, and photographers handles sensitive IP. You cannot legally or ethically upload confidential files to a third-party server. Finally, we have the hardware buyer. You are navigating a highly expensive GPU market, trying to balance your budget against actual in-game performance. Looking at the 2026 tech landscape through these 3 specific lenses cuts out the marketing noise. It shows you exactly which tools solve your actual problems. If your job relies on web traffic, your biggest hurdles are satisfying Google's core web vitals and keeping impatient mobile users from leaving your site before the images even load. The solution is taking your massive libraries of legacy JPEGs and PNGs and running them through free client-side tools that batch convert them into the WebP format. Converting JPEG to WebP is a low-effort, high-impact optimization. It reduces file sizes by 25 to 35%, improving largest contentful paint by up to 30%. However, legacy architectures must support WebP, and pushing to newer AVIF formats requires accepting 8-second encoding times. Many site owners try to bypass this friction by paying a content delivery network to auto-convert images on the fly, but handling this locally in your browser offers a distinct advantage. Doing it locally gives you complete control over the exact quality-to-size ratio of every image before it ever touches a server. The catch is that you are relying entirely on your own machine's processing power, meaning large batches might lock up older hardware. For anyone managing an online store, running local WebP conversion is the most direct, zero-cost method to boost both your search rankings and your revenue. Now consider photographers, medical professionals, and legal teams. In these fields, uploading confidential files to a cloud service is a massive liability. This scorecard compares cloud subscriptions against client-side tools. Client-side browser processing ensures zero server-side tracking, eliminates upload queues, and maintains strict HIPAA and IP compliance. The trade-off is relying on your local compute power and WebAssembly models rather than massive cloud mainframes. Financially, this allows you to cancel expensive monthly cloud subscriptions and replace them with free, unlimited client-side toolkits. But losing those paid subscriptions means losing their integrated cloud storage ecosystems. You are now entirely responsible for your own local file organization and backups. The capability is staggering. Local AI inpainting acts as a magic eraser, seamlessly removing objects from complex backgrounds without ever exposing photos to the internet. Client-side processing eliminates the historical trade-off between accessing AI manipulation and maintaining strict data security. For gamers and 3D professionals, the hardware market has become fiercely expensive. Raw rasterization performance alone no longer justifies the heavy price tag of a modern graphics card. This GPU purchasing decision tree asks, will you accept hardware lock-in? NVIDIA's DLSS4 delivers peak neural rendering and tripled frame rates, but forces vendor lock-in. Alternatively, AMD's FSR4 and Intel's ZSS2 offer broad hardware compatibility with a slight sacrifice in absolute visual stability. Before spending a dime, you can run your system specs through an AI scaling performance calculator. This provides exact, data-driven FPS projections for your specific games. However, you must research how synthetic frames affect input latency compared to native rendering. The efficiency of this tech is undeniable. The AI renders a low-resolution base and instantly reconstructs the missing high-resolution details. The value of your next graphics card is no longer about traditional teraflops. It is dictated almost entirely by the quality of its AI upscaling implementation. The transition from centralized cloud dependency to local AI processing is now the standard for modern media workflows. This 2026 checklist shows who must migrate immediately. E-commerce sites must adopt client-side WebP batching to maintain search visibility. Legal and medical professionals must stop risking confidential documents on cloud servers. Hardware buyers must prioritize AI upscaling and Ray vendor lock-in over raw benchmarks. Committing to this localized stack means you have to abandon the easy convenience of cloud storage and rely entirely on the strength of your own local hardware. But that friction is minimal. Local AI tools give you the speed, the security, and the performance you need, without forcing you to surrender your privacy or your budget to a centralized server.